Get started this practice test. We're just evaluating logarithms. So we're going to say 4 to what power gives me 64? That would be 3. The next one, we'd say 4 to what power gives me 1 over 64? So the 4 goes from a numerator to a denominator, so it's going to have a negative on it. And then that would make 4 going to 64. That'd be a negative 3. The next one, let's think about this. We've got log base 216 going to 36. So what's happening is if I take the cube root of 216, that would give me, the cube root of 216 would be 6. And then if I square that 6, I would get 36. So actually what I'm doing is I'm taking the 216 to the 2/3 power. Right? I take the root of 216, then I square it. So that'd be 2/3. Moving down to the next ones, it says rewrite in exponential form. So that would simply be 3 to the 5th is equal to 243. The next one would be 225 to the negative 1/2 is equal to 1 over 15. On the next ones, I'm taking a exponential and putting it into logarithmic form. So how that's going to work is the base will be 6. The bases stay the same, so I have log base 6. What's outside all alone moves inside the log. And what's trapped in the exponent position goes out on its own. So doing the same thing over here, the base is 13. The 169 moves into the log, and the exponent goes out. Alone, isolated alone. Okay, the next one says simplify the expression. So if I can get these bases to be, if the 3 and this can be the same, then it's going to be whatever the exponent is. So I'm going to say this is log base 3, and now I'm going to change 81 to 3 cubed. To the 2x, so now my exponents would multiply, so I got log base 3, 3 to the 6x, so my answer is 6x. The next one, the bases match, so it's whatever I'm taking the log of. Here's a correction to this one. It's not 3 to the 3rd, it's 3/4. So this is going to be 3 to the 4th. That's going to be 8x. And that makes this 8. Okay, moving down to the where we are simplifying some bases. So here we go. So what we're going to have is the 2 divides into the 4 twice, so that would be 2 as a numerator. And then I have the same base, so I'm going to subtract the exponent, so that would be 2x minus x minus 1. So the whole exponent on the denominator subtracts. That would be 2e, so 2x minus x, that would be 2x minus x, then a minus distributes over to the negative 1, it'd be plus 1. That would be 2e to the 2x minus x, that would be x, and then I've got plus 1. Okay, the next one, I'm going to change this into the 4th root of, since 2 to the 4th is 16, I'm going to say this is 16 times 2 times e to the negative 8x. So the 16 comes out as a 2. So I have 2 times the 4th root of 2e to the minus 8x. So as far as the negative 8x, that would come out, and it would be e to the minus 8x divided by 4 is what's going to come out of there, right? 8x divided by 4. So that's going to be 2e to the minus 8x divided by 4 times the square fourth root of 2. Now this e to the minus 8x, that's 2e to the negative 2x times the fourth root of 2. And now the e to the negative 2x would move down to a denominator position. So I would have 2 times the fourth root of 2 all over e to the 2x to get rid of my negative. Okay, now we're going to be finding the inverses. So the first thing I'm going to do is switch the x's and the y's. So x is equal to the log base 5 of y plus 6. And now then what I have is I have my y is trapped inside the logarithm. To get it out, I simply change it to exponential form. So that would be 5 to the x is equal to y plus 6. And then so 5 to the x minus 6 is equal to y. The next one I'm changing an exponential, first thing I do is switch the x's and the y's. So that's a minus 4 raised to the y power all over 3. So let's go ahead and isolate the exponent part. So I'm going to take both sides times a negative 3. So I have a negative 3x is equal to 4 to the y. Now then I have the y is trapped into an exponent position. To get it out, I'll change it into a logarithm. So what that would be log base 4. Now what's out here all alone moves inside the logarithm. And what's trapped in the exponent position would come out and be isolated. Okay, next couple. It says expand each logarithm. So I'm going to go ahead and distribute that 3 in. So I'm going to have the 3 exponent. So I'm going to have ln of x cubed all over z cubed y to the 18th. And now all my exponents will be in front of the logarithms. Anything that's a denominator will have a subtraction. So the x cubed will be a numerator. So it'll have a plus in front of it, and the 3 will come out because it's an exponent. So that would be 3 ln of x. The z cubed will be subtracted because it's a denominator, and the exponent of 3 will come out. And the y, which is also a denominator, would be subtracted, that logarithm, and it would have an 18 in front of it because it has an exponent of 18. So that would be minus 18 ln of y. Okay, the next one is we are condensing them. So anything that has a plus in front of it will be a numerator. Anything that has a subtraction will be a denominator. So I'm going to combine all that into one logarithm, log base 5. The a will be a numerator because it has a plus in it, and the 5 will go be its exponent. The c will be a denominator because that logarithm is subtracted. It does not have any exponent on the c. And then the b would also be subtracted because it has a negative, and that would be b cubed. And those would all be under the log in the same logarithm. Okay, the next are solves. Now remember, we should check our answers for extraneous solutions. I will not do that on all these so that we save time. But we should do that, so I'll do it on a couple. And we definitely, one thing we want to check for is we want to check for that we're not going to be able to take the logarithm of a negative number or 0. So let's go ahead and start the first one. You need to have whatever. All right, here we go. So the first thing I'm going to do is I need to have whatever I'm going to be taking and solving, which is this exponent thing. We need to have that all alone and isolated. It is. So we're ready to change this into a logarithm, which will free up the x. So this would be 4 to the first. Sorry. I don't know what I was thinking there. So what I'm going to change it to a logarithm. It's going to be the logarithm of base 4. What's outside, all isolated, will move inside the log, and the exponent moves outside isolated where I want it. So now I'm just going to evaluate the 4 to what power gives me 1. That would be 0. So 0 is equal to 3x plus 1. Negative 1 is equal to 3x. X is equal to a negative 1/3. And let's check that. So if I check a negative 1/3, okay, so I have 4 to the negative 1/3 times 3 plus 1 is equal to 1. So I've got 4 to the negative 1 negative 1 plus 1 is equal to 1. 4 to the 0 is equal to 1. 1 is equal to 1. That checks. So that would be a good answer. Let's move to the next one. I'm going to change the 64 to a base 4 on this. So I've got 4 cubed is equal to x minus to the x minus 2 power is equal to 16. Now the 3 is going to multiply by the entire x minus 2. So that's going to be 4 to the 3x minus 6 is equal to 16. Okay, so now then I'm going to change this to a logarithm. Log, the base is 4. The 16 moves inside the logarithm, and the 3x minus 6 is outside. So I would have 4 to what power gives me 16? That would be 2. So I have 2 is equal to 3x minus 6. Subtract or adding 6 to both sides. I've got 8 is equal to 3x. 8/3 is equal to x. Okay, once again, you should check that. I checked it in a previous class and it worked. Just trust me on that. You guys can do it on your own. Here I have an exponent equal exponent. So what I need to do is going to get these bases to be the same. So what I would do is I'm going to change the 16 to 4 squared to 2n minus 2. Here's 4 cubed to the 2n. Okay, so now I'm going to multiply the exponents together. So I've got 4, and the 2 multiplies by the whole exponent up there. So that's going to be to the 4n minus 4 is equal to 4 to the 6n. So now my exponents must be equal since I have the same base. So 4n minus 4 is equal to 6n. Subtracting 4n from both sides, I get a negative 4 is equal to 2n. Dividing by 2, I get a negative 2 is equal to n. Once again, you need to check that. The next one is I have 2 logarithms are equal. There's nothing added or subtracted, so this is a simple one. The bases need to be the same. So I have a negative 2x minus 2 is equal to x plus 4. What's inside the logs must be equal. So I'm going to take this negative 2x and add it to the other side. So I have a negative 2 is equal to 3x plus 4. Now I'm going to subtract 4 from both sides. So that's a negative 6 is equal to 3x, and I have a negative 2 is equal to x. You need to check that. One of your first things is you're going to look to see if it gives you a negative logarithm, and it does not. So the chances are is that could very well work in both of those. Okay, 3 more to do. So what we need to do is we need to isolate the logarithm portion. So we're going to move everything else to their side. And so that's going to be log base 3 of n minus 2 is equal to subtracting 1 from both sides. Now then, to get the n minus 2 out of the logarithm, I'm going to change it to an exponential. 3 cubed is equal to n minus 2. 27 is equal to n minus 2. 29 is equal to n. And let's check that. That's an easy one to check. So check 29. So I'm going to have log base 3 of 29 minus 2 plus 1 equal to 4. Log base 3 of 27 plus 1 equal to 4. 3 to what power gives me 27? That's 3 plus 1 equals 4. 4 is equal to 4. That checks. Okay, let's move over to the next one. The next one, we're going to have to combine those two logarithms, because what I have is I have log minus a log equal a number, so there's no way I could ever get that just to be log equal log. So what this is going to be, that'd be log base 3, and since there's a subtraction there, the 2x would be a numerator and this 2 would be a denominator. Okay, so that's going to simplify. Log base 3 of x is equal to 2. So I've got 3 squared is equal to x. 9 is equal to x. So you can check that. Okay, moving down to what looks like the last solve. Once again, I have a logarithm, 2 logarithms. And I'm going to need to combine those into one logarithm because I have a number in there also. So this would be log base 3, the 5x squared would be a numerator when I combine them. This 5 would be a denominator, and this is too easy. I've got log base 3 of x squared equal to 4. So we're going to say 3 to the 4th is equal to x squared. We'll change it into an exponent. So 3 to the 4th is equal to x squared. 81 is equal to x squared. That gives me x is equal to plus or minus 9. Okay, so we'll have to check those. Let's check just real quick, though. I'm going to let you check them. But let's just check to see if we don't have a negative log, because we do have a negative 9, which is kind of scary. But we can see that the x is actually squared. So that would take the negative off of it. So I'm not going to have a negative logarithm. So that gives me a hope that when I check it, that's going to come out. Okay, I want to make sure we get the last two in. Because we have 4 graphs to do, and those may be a little more lengthy. We should be able to get everything in, but I want to make sure I cover these. So the first thing we're going to do is we have a logarithm and exponential, and we need to see, and it says, okay, it gives us a parent, and then it gives us a graph, and say write the equation of the graph. Okay, so the two things I'm going to be looking for is the asymptote of the parent. So the asymptote of this parent graph would be at x equal to 0. And then I also know that I should have a point that all parent logarithms have a point at 1, 0. Right? So there should be a point here on the parent graph. So the first thing I'm going to do is see where does my asymptote go. For a logarithm, that's going to be a change in the x direction. So my original asymptote should be right here at x equal to 0. And it actually moved 1, 2, 3, 4, 5 away. So that means that in this case, h is equal to a negative 5. So my asymptote shift 5 to the left. So my new equation, which will be g of x, I know is going to have x minus h in it. So that would be logarithm. Base 10, that's not going to change. But it's going to be x minus a negative 5. So that's going to be x plus 5. So there's my shift in the x direction written into the logarithm. And now let's see if there's a y shift. This point that is here at 1, 0, which is on all parent logarithms, that point, if all it had was a shift in the x direction, should be 1, 2, 3, 4, 5. It should be right here. That's where it would go. But it's not there. What's happened to it is it shifted up by 1, 2, 3, 4. So what we also have going on is we have a shift upward of 4, so k is 4. So I can put that out here, and this would be the equation of that logarithm. Okay, let's move on to the next one. Now, the first thing we're going to look at is, I guess I should have mentioned it on the other one, is notice that the base is 10. So I would expect that a base 10 logarithm or any logarithm that doesn't have a fractional base would come up and go like that. And that's what it did. So I wasn't even looking at having a negative on it. Now, this one's a little different because what I have is I have a base e, which means that should be a growth. And since it's an exponential, it should look like that if it's a growth, and it doesn't. So I know immediately by looking at it that it's a reflection, that it's reflected down. So I know that this must have an a value of a negative, right? Some sort of an a value that's negative like that. So it may stretch or something along with that, but I know that it's going to have a negative. I also know that this must have an asymptote at x equal to 0 on, y equal to 0 on the parent. Okay, so that would have an asymptote here, and any sort of shift of that asymptote would be a k-shift. It would be a shift down or up, and I can see that the asymptote of this one actually is y equals to a -5. That tells me k is equal to a -5. So we can go ahead and put a couple things in on this. So my new equation, we've already said it's going to have a negative. It's going to have also a k of a -5 on it, and we don't know if there's an x shift left. So what we do have is we know that on any parent exponential, I have a point at 0, 1. Every exponential will have that. Think of it this way. If I put a 0 in for x, so if I put a 0 for x, I would have e to the 0 is equal to 1. So y would be equal to 1. So once again, I have the point 0, 1. That's on all parent. And let's see, I would expect that if all I had was this y shift downward of 5, it would go down 1, 2, 3, 4, 5. It should be there. That's exactly where it is. So it did not move left or right. So there is no x shift left or right on that one because 0, 1 is where I would think it would be after the shift in the y direction. So that would be the equation. Okay, now we're going to do 4 graphs, and one thing that's different than the instructions say is the instructions say to graph the actually, that's what I'm trying to say is we don't have to graph the parent function. All we have to do is graph the final function, but we do have to have the tables for both. So the parent graph of this exponential would be y equals to 1/2 to the x. That's my parent graph. So let's go ahead and get some points for that. And I can look at this and see I'm going to shift upward by 2. So my asymptote's going to go to 2. I might as well put that on there. It's an exponential, so my asymptote is y equal to 2. So I think I'm going to, and I have a -1/3, so I'm going to use some larger values for x. I pick x, get y. So I'm going to use 3 and -3. So -3, 0, and 3 are the two values I'm going to use, or the 3 values. So I'm going to have 1/2 to the -3. That's going to be 8. And 0, so 1/2 to the 0 is 1, and 1/2 cubed is 1/8. Now then I'm going to shift those, and we can see that what we have is we have x plus 2. So h is a -2, and we have k is equal to 2. I also have an a value of a -1/3. So let's build all that into my shift table. So I'm going to have x minus 2. And for the y, I'm going to have a -1/3 times the y value plus 2. So let's move all my points. So I would have a -1/3 minus 2, that's a -5. And when I put an 8 in there, I'm going to have a -8/3. That's a -2 and 1/3 plus 2, -2 and 2/3 plus 2. So I'm going to have a -2/3. Okay, if I put the next point in there, 0 minus 2, that's a -2. And I have 1 for the y, so I have a -1/3 times 1, so that'd be a -1/3 plus 2. I would have 1 and 2/3. And lastly, I have 1/8, 3 1/8, so 3 minus 2, that's 1. And putting 1/8 in for y, I would have a -1/24 plus 2, so that's 1 and 23/24. So let's go ahead and plot those points. I have a -5, a -2/3. So that'll be about right here. I have a -2, 1 and 2/3. That'll be right here. And then I have 1 and almost 2, so right up against the asymptote. So this will look something like that. And let's see, I need the domain and the range. I already put the asymptote up there. That was y equal to 2. So the domain of this graph is going to be all reals. So x would go from a negative infinity all the way to infinity. And the y is going to be all real numbers where y is less than 2. So the range, we're going to put, it's coming from a negative infinity going all the way up to 2. Like that. So that would be the interval notation. Let's move to the next graph. And we have another one with bad numbers. So let's go ahead and find it's an exponential again. So the asymptote is going to be at y equals a negative 2. So I'm going to go ahead and put that on the graph. And I'm going to make a parent table. The parent is going to be, well, let's go ahead and get h and k. So a here is a negative 1/3. H is equal to 1. K is equal to a negative 2. So my parent graph is y is equal to 2x. And I have about the same kind of numbers, so I'm going to go from a negative 3 to a positive 3 again. X, y on my parent graph. So I've got a negative 3, 0, and 3. So 2 to the negative third, 2 to the negative 3, that would be 1/8. 2 to the 0 is 1. 3 cubed is 2 cubed is 8. There's my parent graph. Let's go ahead and make my shifted graph. Hope I have enough room. So I've lost the shifts. Let's see what they were. So I'm going to have x plus 1. And the y is going to be a negative 1/3. Y minus 2, it looks like. Okay, so there's my graph. So let's see. I have a negative 3 plus 1. It'd be negative 2. I'm going to have a negative 1/3 times 1/8. That's a negative 1/24 minus 2. That's a minus 2 and 1/24. Putting 0 in, I got 0 plus 1 is 1. 1 times a negative 1/3. That's a negative 1/3 minus 2. That's a negative 2 and 1/3. And lastly, I've got 3 plus 1 is 4. And if I put 8 in there, I get a negative 1/24. So, wait a second. Oh, no, I get if I put 8 in there, I get a negative 2 2/3. I get a negative 4 2/3. Okay, moving on and graphing this. So I have a negative 2, a negative 2 and 1/24. So a negative 2, a negative 2, and 1/24. So that's going to be about right there. I'm going to have 1, a negative 2 and 1/3, a negative 1, a negative 2 and 1/3. And then I've got 4. Wait a second. Plotted that point wrong. I've got 1, a negative 2 and 1/3. And then I've got 4, a negative 4 2/3. Okay, so there's that graph. Oh, domain and range. Okay, so the domain is, once again, it's all real numbers. And the range are all the real numbers that are less than a negative 2. So it's coming in from a negative infinity going to a negative 2. Okay, doing the logarithm graphs. Okay, so I need to have a parent. First thing, let's go ahead and get h and k. So h is equal to 2. K is equal to 3. So I know that my asymptote is an x asymptote at x equal to 0. It's going to shift to asymptote is x equal to 2. All right, so here's my parent. Y is equal to the log base 3 of x. And let's get some x and y points. Okay, this time I'm going to pick a y, get an x. So I'm going to pick a y of -1, 0, and 1. So when I put a -1 in there, I've got 3 to the -1. That's 1/3. I've got 3 to the 0 is 1, and I have 3 to the 1 is 3. So let's go ahead and shift those. So what's going to happen is I'm going to have x plus 2, and the y value is going to be y plus 3. Okay, so I'm going to have 1/3 plus 2. That's 2 and 1/3. The y value is a -1 plus 3 is 2. I have 1 plus 2 is 3. 0 plus 3 for the y is 3. And then I have 3 plus 2 for the x is 5. And 1 plus 3 is 4 for the y. So I'm going to go ahead and plot those. I've got x is 2 and 1/3, 2. So 2 and 1/3, 2. I have 3, 3. And I have 5, 4. 5, 4. So this one is going to come up along the asymptote, swing out. The domain is going to be all real numbers where x is greater than the asymptote, so that's 2. So the domain is going to go from 2 to infinity, and the range is all reals. And the last graph, this is going to be a decay. Notice that what we have is we have this exponent that's fractional, so I would expect this to come down from the top and look like that. So let's go ahead and get our parent table. The parent is going to be y is equal to the log 1/5 of x, xy. Okay, put the same values in, -1, 0, and 1 for y. We pick y, get x. So what we're going to have is 1/5 to the -1 is 5. We have 1/5 to the 0 is 1, and 1/5 to the 1 would be 1/5. So there's my parent graph. Now what's going to happen? I have h equal to 1, k equal to 3. So I'm going to get this kind of a shift. It's going to be x plus 1, y plus 3. So my asymptote is going to shift over to h. So the asymptote is going to be at x equal to 1. And let's go ahead and shift these points. I've got 5 plus 1 is 6. And the y is a -1 plus 3 is 2. Moving to the next point, I have 1 plus 1 is 2. 0 plus 3 is 3. And then I have 1/5 plus 1 is 1 and 1/5. And I have 1 plus 3 is 4. So let's go ahead and plot it. I have 6, 2. Actually, 6, 2. And then I have 2, 3. And then I have 1 and 1/5, 4. So this one is going to come down from the top, swing out. Like, wait, I don't know why I dotted it. Like that. And I guess we're ready for the domain and range. The domain is going to be all x values greater than the asymptote. So it's going to be from 1 to infinity. And the range is going to be all reals. And that is every problem, I believe.